Hi everyone, my name is Sam and welcome to my Next-Gen AI Guy YouTube channel. In this video, we will going to continue our advanced method to enhance naive RAG with the LangChain and LlamaIndex. In the previous video, we have covered that query construction, how to build text to SQL, text to cipher and text to vector. So we have covered the both thing, the theoretical plus practical part with the help of VS Code. In this video, we will going to focus on a query translation and routing. Before jumping to the query translation, if you have not watched the query construction, how does it work, and I have explained how this retrieval augmentation techniques works, everything I have explained from the scratch. So first watch that query construction, you will get a better idea. In that previous video I have explained how that naive architecture works and what are the ways we can improve it. So now let's jump to the query translation. So here we can see that we have a query translation which is further divided into a query decomposition and pseudo documents. You must be thinking that what is a query translation? So query translation in a retrieval augmented generation refers to a process of transforming the initial query into a various form or subqueries that can enhance the retrieval process. So main objective over here to transform your query means whenever the user will ask any query, that query will be transformed for better retrieval. Sometimes what happens that user is not able to write a perfect query. So because of that, the accuracy of retrieval documents is not that good. So that problem we will going to resolve with the help of query translation. This query translation where we are going to use, I will show you. So whenever the user will ask any query, that query will be used to do similarity search with the documents which is stored in this vector DB. So if you have not written a perfect query or your query is not able to retrieve the perfect document from this vector DB, so that problem we will going to resolve with the help of query translation. The query translation is further divided into a two part. First is a query decomposition, the next one is a pseudo documents. So in this query decomposition, we have a multi-query, step back and RAG fusion. What exactly this query decomposition do? Query decomposition involves breaking down a complex query into a simple subqueries. This can help in cases where a single query might be too broad or too complex for an effective retrieval. So in those scenarios, we will use query decomposition to transform our queries. In query decomposition, we have three methods: multi-query, step back and RAG fusion. So these are the three ways we can implement this query decomposition. So multi-query, whenever you will write the query, from that query with the help of LLM, we will going to generate multiple queries. So each generated queries will be individually going to retrieve the data from the vector DB. So that's how multi-query will work. Then step back we have, and the last one is a RAG fusion. The only difference between the multi-query and the RAG fusion is that in the RAG fusion we also going to generate a multiple query. So the difference is multi-queries will going to generate multiple queries and individually it will going to retrieve the data from the vector DB. And in case of RAG fusion, it will also going to generate a multiple query, and that queries will be retrieve the data from the vector DB. That retrieval documents will be ranked with the help of reciprocal rank fusion formula. That formula I will going to show you in the code, and how does it will work. Everything I will going to show you from the scratch. So next one we are having a pseudo documents. What exactly it is? So how does it work? Whenever you will write the query, so it will going to generate the hypothetical documents. What should be the answer of that query? That query answer will be generated with the help of LLM, and rather than doing the similarity search between the query and the vector DB, here what will going to happen, the generated response by the LLM based on the query, that generated response will be used to do similarity search with the documents which is stored in the vector DB. So we are not doing a similarity search between the query and the documents. We will going to do a similarity search with the generated of that hypothetical answer by LLM. That hypothetical answer will be used to do similarity search with the vector DB. So you can imagine that based on the similarity search, the chances will be increased to retrieve the more relevant document, because whenever you will ask the query, that query's answer is already generated by the help of LLM, and we are not going to use the query to do similarity search. We are going to use that hypothetical answer. That answer we will going to use to do similarity search from the vector DB, and that retrieved document will be fed for a large language model for final output. So that's how the pseudo documents works. So we have seen the theoretical part of query translation. Now we will move forward to how to implement these all techniques in the VS Code. We are able to see over here that query translation. Don't worry about the code. GitHub link I will provide in the description below. You can check it out from there. So let's first go with the multi-query. How does it will work? So over here what we are doing, we are importing the packages. Here we have first imported OS operating system. Next we are importing the Chroma, which is a vector database which we are importing from a Langchain underscore community dot vector stores. So we are already, if you have watched my previous video, you are aware of that the Langchain is a framework which allows us to build LLM based application. So this is the embedding model which allows us to convert our documents into a vector format, which is a numerical representation of the text. Next we are importing chat OpenAI from Langchain underscore OpenAI. We are using a LLM model from the chat OpenAI. You can use the ChatGPT 3.5 Turbo or ChatGPT 4.0, which is recently launched. That one also you can use it. So next we are using a multi-query retrieve. So this is, we are importing from a Langchain. So this is the inbuilt package from the Langchain we are importing. This multi-query retriever help us to, whenever you will write the query, that query will be converted into a multiple queries, and queries will be individually going to retrieve the data from the vector div. So that work will be done by this multi-query retriever package. Next we are importing the load.env file, which is crucial to load the all credential which you have written in this .env file. After that we are importing warnings just to ignore some, whenever you will run the module, sometimes it gives a future warning. If you want to ignore those warning, then you can use this warning module. Here we are using logging. By the name it is understandable to log the status or whatever you wanted to log, that you can do with the help of this logging module. Here we have given the path of our vector db where we wanted to store the data. So Chroma DB provide us the persist directory function, which allows us to store our vector DB in our working directory, or you can say in a local disk. We are initiating our sentence transfer embedding. The model which we are using over here is All-Mini L6 V2. I will going to give the Hugging Face embedding model leaderboard. From that leaderboard, based on your requirement, that embedding model you can choose from there. So just for a demo purpose or to explain, I have just choose this All-Mini LM L6 V2. Next we are initiating our Chroma DB where we wanted to store our data. So in this we have provided the persist directory where we wanted to store, and next we are providing the embedding which we have written over here. After that we have initiated our vector db as retriever. Over here we have passed the search keyword argument k equal to 1. This means only wanted to retrieve one document. If you wanted to retrieve 2 or 3, that you can change according to your needs. In case you wanted to go with the other methods like this retriever, we have several kind of retriever like similarity score threshold or the maximum marginal retriever also we have, that you can check it out from my first video. So after that we are initiating our large language model. We are using a chat OpenAI model. Over here we have provided temperature equal to 0 and API key. Here you just need to paste your API key, or you can paste it over this .env file and you can import it with the help of load.env. Next we have written the multi-query retriever. Based on the user query, it will going to generate a multiple queries, and those query will be individually going to retrieve the data from the vector db. Okay, so here we have given a vector db dot as retriever. You don't need to write this because I have already initiated, so just copy this one and paste over there. This will going to call the vector store retriever which we have written over here, and we have passed the search keyword argument k equal to 2. It will going to retrieve the 2 documents, and we have passed our large language model which is chat OpenAI. If you wanted to use the specific model, that model name you can pass over here. Next we have given the question, and after that we are just invoking our multi-query retriever. Then you just need to pass the question, and based on that it will going to generate the multiple queries. Queries will be like this, that queries it has generated, and individually query will be used to retrieve data from the vector db. This is the way to improve our naive-rag. So you know that sometimes query is quite complex, which is not able to retrieve the exact answer which we are looking for. Dividing that query into a multiple sub query will going to solve that issue. That how the multi query works. Now we will move forward to a rag fusion. So RAG fusion generally refers to the method of combining information from a multiple retrieved document to generate a single or coherent response. So first it will going to do query generation, then it will going to do sub query retrieval based on the whatever queries it has generated. That queries will be used to retrieve the data from the vector DB, and with the help of reciprocal rank fusion we will going to merge the retrievable document using a reciprocal rank fusion to combine their ranks and prioritizing the most relevant and comprehensive result. So that was the way we were going to implement this. Over here we have first imported our dumps and load whatever you wanted to store or whatever you wanted to load, we can do with the help of langchain.load. After that we have imported our chat prompt template, which allows us to give the prompt template or whatever instruction you wanted to give to LLM, that you can do with the help of chat prompt template. Next we are importing our string output parser from the Langchain_core.output parser, which allows us to parse the LLM response into a string format. Next we are importing a chat OpenAI to use the LLM model. After that we are importing the Chroma, which is a vector database. Then we are using a directory loader. Directory loader, we will use it to load all the documents which is stored in a particular directory. Next we are using recursive character text splitter. It will going to split the documents recursively. Next we are using a sentence transfer embedding. Embedding allows us to convert text data into a vector, which is numerical representation of text. After that we just have provided our template over here, like you are a helpful assistant that generate multiple search queries based on a single input query. That instruction we are going to feed. So that template we will going to provide the chat prompt template, which we have imported. I have shown you. These things allows us to give the instruction to LLM model. So after that we are just initiating our LLM model. You just need to provide your API key over here, and here we are passing our directory path. So after that you just need to provide in this directory loader function, which we have imported from LangChain, and this show progress will going to tell that how much it is able to load. Next we will going to initiate this directory loader, so it will start loading the documents from the directory. Here we have used a recursive character text splitter, which allows us to split the documents recursively, and here we have provided our chunk size and chunk overlap. The chunk size is 200 and chunk overlap is 20. So what is chunk overlap? Chunk overlap means if you have two chunks of document, so first chunk's last 20 words will be present into a next chunk first 20 word. So next we have started the splitting our documents. Why do we split? Because handling the large amount of data will be difficult, and we have a particular context window of all the LLM model. So we won't be able to feed the whole documents in one go. So after that we are splitting the documents and storing that documents in this docs variable. So after storing the documents in this docs variable, next we are initiating our embedding model, which we are using Almini LM6 from the sentence transformer embedding. After that we are storing our documents in this Chroma database. So here we have provided two variables. First is the document, which will take the splitted documents over here. Next we are the embedding model. So what it will do, it will going to embed the documents and store into this vector DB. Next we are using the vector dot as retriever, so this will allows us to retrieve the document. If you wanted to pass over here the search keyword arguments, that also you can pass, which will allows us to retrieve as many as documents you are looking for. So next here we have created a chain. This is also a way to create a chain. So here we have passed the prompt RAG fusion, means in this variable we are storing our prompt, which is over here. We are using a chat prompt template to define our prompt. So that prompt we are passing over here. Next we are passing our LLM model, which is chat OpenAI. Next we are passing string output parser, which allows us to parse the LLM output into a string format, and that all question we are going to split and store into the list that we are doing with the help of lambda function. This is the main part. This is the reciprocal rank fusion, so which allows us to rank the document. Main thing over here is the formula which we have written over here. This is the formula which we will going to use the rank our document. So how we are going to do that? Here we have created a variable to store our data into a dictionary format. So here if we have one by one, we will going to iterate the documents from this result function. In this we are just taking the rank and document from this docs file, and if the rank is not over there, then initiate from the 0. Next, we will going to give the score with the help of this reciprocal rank fusion formula. After that, we are just sorting this document in a descending order. So finally we are returning our re-ranked result variable. So here we have passed our query. For simple use case, I've just given what is a knowledge graph, and here we have created the chain which will take the generate queries, retriever.map, and reciprocal rank fusion function. Generate queries is over here, which is main motive of the generate queries to generate the multiple queries based on the question it has been provided. Next, we are using a retrieve.map function which will help us to retrieve the documents from the database, and here we have used the reciprocal rank fusion function which allows us to rank our documents. So after that, we just invoking the retrieval chain rank fusion by providing the question. Here we are just creating the length of the documents, and this is the template for a final output. Till this part, what we are doing, generating queries, retrieving the documents from the database, and we are ranking that re-ranked documents will be given to the large language model for a final output. So that part we will going to do over here. Here we have given the template. That template we will provide in the chat prompt template, which allows us to give the instruction to the LLM model. And final RAG chain we have created by using the retrieval chain RAG fusion, which is over here. And then we are taking the question. This is the context, means from this we will going to re-rank documents and the question we are taking. So we will going to send the re-ranked documents plus the question to the LLM model for final output. Here we have given our prompt. So this is the prompt, and next we are using LLM model and string output parser to parse our LLM model output into a string. So at last we are invoking our final RAG chain by providing the question. By invoking this chain, first it will going to generate the multiple queries. That queries will be used to retrieve the documents, and that retrieved documents will be re-ranked with the help of reciprocal rank formula, and that ranked documents will be fed to LLM model for final output. So that's how we build a RAG fusion. Now we will move for a HyDE. HyDE is a hypothetical document extraction. So in this we will do with the help of LangChain plus LlamaIndex. Both are the frameworks which allows us to build LLM based application. First we will see with the help of LangChain, then we will move forward to LlamaIndex. So let's go with the LangChain. So here we are importing. Till right now you must be aware of this, all these things. Still I will going to explain you, so it will give you better revision. So this kind of information will be stored for a longer time. So this is the chat prompt template which allows us to give the instruction to LLM model. Here we are using string output parser which allows us to parse the LLM output into a string format. Next we are using chat OpenAI for LLM model. Here we are using Chroma for a vector DB. You can use the face or pinecone as well as faces from Facebook. That one if you wanted to use, you can. It also provides the persist directory, means you will be able to store vector DB into your local disk. Next we are importing directory loader. Directory loader allows us to load the documents from the given directory. Here we are using recursive character text splitter to split our documents recursively. Next, embedding model from sentence transformer, which allows us to convert the documents into a vector which is numerical representation of text. Here we have provided our directory path. We are initiating our directory loader module. Here we are splitting our documents with the help of chunk size and chunk overlap. Next we will initiate our split documents. After that we have just given over here embedding model. So in this case we are using all many L6v2. So that embedding model we will going to use to convert text into a vector. Here we have the Chroma DB which will take the document plus embedding, and these documents will be converted with the help of embedding model and stored into the vector database. Here we have given the vector retriever function, so that will allows us to retrieve the document from the vector DB. After that we have initiated our large language model. It's a language model, means why we called it large, because it has been trained on a huge amount of data. That's why we called it large language model. Next we are providing our template where we have given the instruction, and that template we will going to feed in this chat prompt template. After that we are just in creating a chain. What it will going to do, whenever you will ask the query, that query first will be fed to LLM for a hypothetical answer. That answer we will use to do similarity search from the vector DB to retrieve the data. Based on the hypothetical data extraction, the accuracy will be more. The retrieved data will be relevant to the hypothetical answer. That chain we are creating over here with the help of prompt hide, chat OpenAI LLM model, and string output parser. So here we are passing prompt hide, LLM, and string output parser. Next we have just given our question. Again we are creating a chain. So first chain is to generate the hypothetical answer of that given question. Next, this chain allows us to retrieve the documents based on the hypothetical document. So here we are passing the generate docs for retrieval. Over here that chain will going to generate the hypothetical answer, and here we are passed the retriever function, means based on the hypothetical answer it will going to do similarity search from the vector DB and it will going to retrieve the output. Here we have just invoke our chain by providing the question over here. This is the part till retriever. Next part we will going to feed that retrieved documents to the LLM for a final output. After that still we are feeding to the LLM for a final generation of output. So here we have fed the template what we wanted to do. Just it's a simple template which is telling the answer the following question based on this context. So we have provided two variables, context and the question. These two variables we have to pass when we are invoking our chain. So first will be this context from the retrieved documents, and next we are taking the question which is the user question. So here we have given the prompt template, and after that final RAG chain we have created. In this chain we are feeding the prompt, LLM model, and string output parser. This final RAG chain we are invoking over here. I have told you that we have to feed two variables, context and the question. Context is a retrieved document based on the hypothetical docs created by LLM, and the user question we are feeding over here, and based on this context and question final output will be generated. So that's how we can do the hypothetical document extraction. Now we will move to the LlamaIndex, how we can do the implementation with the help of LlamaIndex. So it's quite a simple code. So over here first we are importing the vector store index and simple directory reader. So this is the same as a directory loader from the LLM model. Here you just need to pass your directory path and it will going to load the documents from that given directory, and the vector store index to store the documents. And next we are using the hide query transform. This is the already inbuilt library from this LlamaIndex, so that we will going to use to generate the hypothetical document based on the query. Next we are using transform query engine. This will take the two things. The first is the hypothetical document and the second one is the vector DB where the data is stored. Based on that it will going to retrieve the final output. Here we have imported load.env to import all the credential from this .env file. Next we are initiating, it will going to load the data with the help of simple directory reader. Here we are storing our that documents. If you wanted to split the documents, that also you can do. You can do with the help of recursive text splitter or a simple text splitter. So here we have passed our document and that document will be stored with the help of this vector store index. Main thing over here, this is the index engine. We are creating an engine as a query engine. You just need to feed your query and this engine will going to retrieve the similar data based on the query you have provided. So here we are not feeding the query, we are feeding the hypothetical document. That document will be used to retrieve the document. So after that here we have given the hide query transform which allows us to the hypothetical answer will be generated over here. Next we are running the transform query engine which will take two things, query engine where we have stored our data and the hide means the hypothetical documents generated by LLM. So this hide query transform will automatically going to generate the answer. Here we are passing the query engine and hide. So after that we just need to give our query and that query we are feeding into this hide query engine, and based on that final output will be generated. So that was the way to do with the help of LangChain and LlamaIndex. So we have covered this query translation in depthly. In that we have learned that query decomposition plus pseudo documents as well as. So all these steps we have covered. Now we will move forward to routing methods. What are the routing methods we have and why do we need it? First we will going to cover the theoretical part. After that we will move to the coding part with the help of VS Code. So we have two type of routing, logical routing and semantic routing. What exactly happens means whenever you will write the query, your logic decide which database to choose. Sometimes what happens that you have a multiple database. Okay, so whenever you will write a query, your logic will decide that should I go for this database or that database. So that decision is depending on this routing. method. So either you can write your logic over there, or you can use LLM model to decide which database to choose. So in this logical routing and semantic routing, there is a small difference. What exactly it is, both is used to choose the which database, but in case of logical routing, you just have written like if else statement, or you're just using a LLM model to decide which database to choose. Okay, that prompt you have given over here. In case of semantic routing, what it will do, it will going to similarity between those two predefined prompts. In simple way, with this prompt it is written about a particular database, so in what scenarios you should choose this database, and in this second prompt we have written other scenarios you should be choosing this database. Your query will be embedded with the help of embedding model, then it will going to do similarity search with this both prompts. Based on that, it will going to choose. Now let's just move to the coding part, how to implement this logical and semantic routing. So here we are having a routing in which I have written logical routing and semantic routing. It's quite simple. Both we are doing with the help of LangChain. So in case of logical routing, here we are importing our packages like a chat OpenAI for using LLM model, load QA chain, which allows us to create question and answer chain with the different components or tasks. Here we are importing simple vector store, or if you wanted to use a chroma db or face db, that you can do also over here. So next we are initiating our large language model, and this is the simple documentation. Imagine that you have a three type of document. One is the web documents. Over there all the information about is related to this HTML, CSS and JavaScript. That information is stored in this web. Next we have this database. This is the information which is related to database, and fact means you have a like how to reset my password and how to contact support. These are the kind of information is stored in this variable. So next we are storing those documents to a vector db. So here we have stored the data. Main important thing is over here is that the logic. In the case of logical routing, we have written the logic, simple logics. In that query, if web is present, then it will going to return web, and based on that it will going to choose the vector db to retype the database. So that's the main logic over here. Simple logic you have written, or you can use the LLM model to decide which database to use. So this is the simple logic we have written. If web is present, choose web. If database is present, then choose database. Else if nothing is present, then you can use web. So based on that, it will going to retrieve. So this is the main logic over here. After that, here we have written the generate answer function. So after that we have written three functions. First one is a retrieve documents to retrieve the document. The next one is generate answer. Based on the retrieve documents, we wanted to generate the answer with the help of LLM model. Final is the answer query. In this function we will going to use the other two function, because logical routing answer is dependent for this retrieve document function. The logical routing will going to choose that which database to choose. So that database decision is stored in this variable. That variable we will going to pass into the retrieve docs, and then final answer will be generated with generate answer function. So generate answer function will take the query and the retrieve documents from this chosen database. So based on that, generate answer will going to use the LLM model to generate the final answer based on the query and the retrieve documents. Here we have just written the query. So that query we will going to feed into this answer query function, and the final answer will be printed. So that was the way to implement this logical routing. Now we will move forward to a semantic routing. How does it work? So in case of semantic routing, here we have imported our packages like cosine similarity. Whatever query you will going to ask, that query will be embedded. We will use a cosine similarity and do the similarity between that query, the other two prompts, to choose which database to use. The string output parser will allows us to parse the LLM output into string format. Here we use the prompt template, which allows us to give the instruction to LLM model. This is the runnable lambda and runnable pass through. Whenever you are creating a chain, that chain you can pass the input variables while running the process. Next we are importing the chat OpenAI and OpenAI embedding models. So here we have given the two prompts. First one is the healthcare prompt, the second one is technology prompt. Whenever you will going to write the query, that query's similarity search will be this health prompt and the technology prompt. For example purpose, I have taken two prompts, which is first is domain related to healthcare, the second one is domain related to technology. So if your query is related to healthcare, then it will choose the health database. And if your query is related to technology, then it will going to choose the technology database. So here we have given the embedding models, and those two prompts we are taking in this prompt text as a list. Next, we are embedding these prompts. We will going to embed, store in this prompt embedding variable. Next, this is the function. Here is a semantic route we are creating that will decide which is the most appropriate prompt according to your question. First, we will taking the query over here. That query we will going to embed, and then with the help of cosine similarity, we will going to do the similarity between this query embedding and the prompt embedding over here. We are just doing the similarity search with only first one. If this is not the case, then we have to choose the technology. So here we have given the query which we are passing with the help of runnable pass through, and here we have passed the runnable lambda prompt route. This is the prompt router function we are passing with the help of runnable lambda. Next, we are passing the LLM model, the string output parser, to parse LLM output into string format. Finally, we are invoking the chain by providing our question. By providing the question, it will first do the embedding on that question, and then it will going to do the similarity search with the help of cosine similarity from these both prompts. Based on the final route chosen from that database, it will going to retrieve the output. So that was the way to implement this semantic routing. We have completed our routing both way, logical routing and semantic. So that's all for today. We have covered the query construction, query translation, and routing. After that, the three things is left: indexing, retrieval, and generation. Each one we will going to cover in depthly in my upcoming videos. So if you found this video informative, please like and subscribe for more such videos. Thank you.